in RT Nagar now.
Very far from here to.
Hey.
Which
Good morning.
place you are in?
Good morning, Shiva.
Hey, hi, Mamta.
Hi, Shiva.
Yeah.
Shiva, when do you get to sleep? Every day you will wake up early, right?
Yeah, I go to sleep around 11 o'clock.
Oh, that's better. At least I go at 12, 12:30. Shiva, I need a favor from you.
Yes, Mamta.
That still I add a function, the function taking the method taking the function. It's a bit confusing to me. I don't know why.
Okay, did you practice any examples around that?
No, I was concentrating today. I got a little bit of time on list, not on the IRDF function.
Okay, try to perform.
I tried one or two examples.
Yeah, try
Sorry?
the examples that I gave you there. Okay.
Okay, I'll go through this time, and if not, I need your help.
Okay.
In the list, what will that, what is that? Left something is there like fold left, reduce left. What exactly? I could not get it. Reduce left, what will it do?
We'll discuss that during Spark session.
Okay.
We'll get all those things there.
Okay, okay.
Okay. Yeah, let me start sharing my screen. Yeah. So yesterday we talked about so what is a class? What is an object? So how do we declare a methods? How do we declare a constructor variables? And inside the class variables, if there are any. Okay. And the primary constructor and auxiliary constructor. So till that level we talked about. So I would recommend you to run some examples around that. Then you will get even more better understanding. Okay. Now, let's see the inheritance comparison. The same inheritance that we have seen in Java, the same concepts holds good here. So let's see that both in Java and as well as Scala. So just by comparing them, those two. So in one single shot, they both are very similar, like extending a class in Java and as well as extending a class in Scala. They both will inherit the class variable, constructor variables, and all the the methods that we are getting from the parent class, they will get inherited into the child class as well. Okay, so there are minor differences that we will talk about now. Anyway, we'll see this concept. So I hope everyone is aware of inheritance from you. Okay.
Yeah.
So just to quickly give you like, so inheritance is nothing but getting the features of your one of your class into the one another class by extending that class. So it's like a more general features will be placed in a parent class and specific features will be kept in child classes. So for example, if we take person is a general class, and under this we can take a student as a specific class and employee as a another child class for the parent person, right? And similarly, vehicle is a general class, and some of the its child classes you can take car, you can take ship, you can take anything else also, right? So that way, so any common features that you feel like that you can place in the parent class, and specific methods or specific features, specific attributes, you can place them in the child classes. Now, if you observe in this example, what I am trying to do is, so I have a class vehicle and I have some 3 attributes for this vehicle. So they are like the vehicle ID and vehicle manufacturing year and vehicle model. Okay. So for better understanding of this access modifiers also, so I have considered, so one out of them, the public, the vehicle ID is a public integer type and year is a the private scope. So private means, so within this class only this year is available, this year can be accessible. So public means this can be accessible outside of this class also. So once you have the object name, so you can allocate that. And public final string, this is a constant model. So as of now, it is not initialized. Once it is initialized, we cannot change that again and again. Now, so this vehicle is a one constructor which takes ID, year, and string model as the constructor parameters. And those 3 things, we are setting those 3 things to this class variables. Okay. Now, I'm just overriding one of the toString method which is present in the superclass object and returning. So this will return just ID, this dot ID, year and this dot year, model and this dot model. Okay, so that is what all the parent class does. And now I have a child class So this is still a Java code only. Okay, let me show you. So so that is all that Java class. Now I have one of the child class in Java itself. So I have a car, which is extending vehicle. So along with those three attributes, I have two more. So one is a new attribute fuel level, and I'm trying to override the model again here. So if I don't declare this public final string model in the child class, so whatever my superclass gives me, that model, the same thing that I should need to carry forward that. So once that is initialized there, so I will not be reinitializing that here. So now, if you observe here, so in the car constructor, I am taking 4 parameters now: ID, year, model, and fuel level. Now, by passing these first three parameters, ID, year, and model, I am calling the superclass constructor. Okay, so my superclass, my parent class constructor, I am calling there. So if I pass the same ID, year, and model, so this constructor, vehicle constructor, will get called on, and this dot ID, this dot year, and this dot model will get set up. And so after that, I'm again reassigning a value to model here. So this dot model. So this model, whatever I am passing, this will set the model of your parent class. So I'm just showing you the Java concept. Okay. This will set the model of the parent class, but here this dot model means your car class model type. Okay. So I statically made it like a Maruti. So it's like a hard coded. So this dot fuel level, whatever I receive from this constructor parameter, that I am setting up here. So if I use from the same variable, I would not be able to make any difference. That's why I have overridden this value here. So this dot model in the car, and whatever the model that you pass from the constructor parameter, that will be sent to the parent class constructor. Okay. Now in the toString method, so I am returning super.toString. The superclass.toString will get called first, and then in the child class, I'm calling that, appending to that string fuel level, and what is your car class model type. Okay, and what is this dot model, and what is super dot model, what is your superclass model. Now I'm creating an object of car by passing ID as 1, year of manufacturing year as 2016, and model as Ford, and fuel level as 100. Okay, so this is purely your Java inheritance class that I'm trying to show you. Just let me stop. Just stop me if you are not able to understand.
Shiva, it is all in Java, right? Whatever you are
yes, currently I'm trying to show you in Java. So
Okay.
based on this, I will show you in the Scala.
Okay. Thanks, Shiva.
So you can observe that .java means add.
Okay. I didn't look at it. Thanks.
Okay. Yep. Now, so if you see here, or if you want to debug this, instead of running this, if you want to debug this, so that is the better way I can explain. I hope if you are already aware of Java, so then it might be a bit boring you, but just bear with me. Okay. So the first executable statement in my public class and main method is the creation of an object. Now, so where is it going then? Oh, I should have called step into. Let me re-debug that. Step into. So what I will do is I will put some other breakpoints here. Let me do that. Okay. Into the objects creations. Yeah. Now, so since I'm creating a car object, so it is inside the constructor of your car, right? So by taking all those parameters, so ID as 10, and this has a 2016, and model as 4, and fuel level as 100. Correct? So I pass the same values. Now, so it is going to call the superclass object. Let's see. So superclass object in the sense, so now it came into the constructor of your vehicle. So here, so it received all those three, 2016 and model as 4. Now I'm just printing them year 2016 but this dot year and this dot ID. So why I received 2015? Because I just initialized them. So both int ID and int year are like a variables, whereas string model is a constant. Okay, so ID and year are variables. I already initialized them, so I'm just trying to refer them here. This is the place where I am overriding them. Like, so now this dot ID becomes 10, and this dot year will become 2016. You can see that, and this dot model became so 4. Now, so I will be into my car class. So private int fuel level is 0, and so this dot model is getting overridden now. So inside this, you can see here. So this dot model will become Maruti, and this dot fuel level is 0 as of now. So once I reassign, it became 100. So now after this, so system.out.println. So inside this, so did I keep the breakpoint here? So it's going to super.toString. So this is pointing to my vehicle class toString. I'm going to return now this dot ID, which is 10, and this dot year, which is 2016, and this dot model Ford, whatever I have received at the time of vehicle constructor. Now, so along with that fuel, this dot fuel, which is in the child class, which is 100, and this dot model, so which is Maruti. So in this car class, I have statically overridden that constant value. And here super dot model, so still points to that Ford. So finally, I can see ID 10, year 2016, model Ford, fuel 100, and Maruti is from the child class and Ford is from the parent class. So I hope everyone is clear with the inheriting the parent class variables. These two are variables, so I am able to override them. Let's say if I give 1 here instead of 10, or I don't need to worry about that. So in the car class object, I am passing 2016, whereas in my vehicle class, year is 2015 by default if I don't pass anything. Okay, but still when I create my object, so my year is still 2016. Whatever I passed in the child class constructor, that overrides the parent class year. And similarly, the model I pass to parent class, so this is a constant. So even constant I'm able to override. When constant also I'm able to override, and you can see constant is a 4, which is in the parent class it is 4, but in my child class, so in my parent class, I still see the super dot model means I can still see the 4, but in my child class I'm able to override that field as this dot model equal to R. And obviously I can override the ID, I can override the other two as well. So in my child class constructor, I am able to override all these parent class variables. Whether they are variables, whether they are constants, no matter. Both are same for me. I'm able to override them. Okay. So you'll understand why I'm trying to show this. Now it will become
When you say this dot here, everything is from the current
current
scope,
object.
right?
Yep, current object. So super dot any field. So that will be from your
The
parent.
super class,
Correct.
parent class, yeah.
So I'm still in Java. Here you can see I overridden the ID as 20 in my child constructor, like this dot ID equal to 20, and year became 2016, even though in my parent class ID is 10 and year is 2015. I have overridden those two variables, and I have, when I call the println of C, the constructor of your child class, I'm in turn calling the super dot toString. So which is meaning I'm not executing the toString of the parent class directly, whereas I have overridden the same method. So inside that I'm executing this. Okay. For simplicity, for ease of implementation, I'm making use of the superclass toString method also in the implementation of the child class toString. Now, so what I am trying to conclude here is that you can override the variables, you can override the constants, you can override the methods. Okay? And by default, when you create an object of a subclass or a child class, whatever the fields, whatever the methods that you refer on the subclass object, they will refer to your child class methods and child class variables. And inside that, you may be able to refer your superclass fields and methods. Okay? So this is your Java inheritance concept. Now coming to the Scala. So in Scala, in the class declaration itself, as we have seen, we'll specify the constructor variables. So here, when we talk about the constructor variables or the constructor parameters, so we have some limitations. There is one minor change. First, let me show you this example as it is. I have a vehicle class, ID and year as parameters, constructor parameters. So these two are constructor parameters. Whenever I create a vehicle object, these two will get initialized with the values that I receive from the object. But I have two more variables or two more parameters or two more attributes for my vehicle S. So those are class level attributes. They are not constructor level attributes. Okay? They need not to be set every time when I create a vehicle object. So those two are like a model. Model is Fiesta and brand is Ford. I have two attributes. Now, so I have a toString method, the same toString method overriding. If you observe here, so the difference between Java override and Scala override, the same function that you are writing def toString, but the override keyword you are prefixing before the def. Whereas in Java, we are using the annotation at override. Okay. So I want you to notice that difference. In Java, we are using at override annotation, whereas in Scala, we have that override keyword. So just override and specify that. So this override def toString overrides this toString method of the Java superclass object. Now, so that is anyway fine. This is our base class. Now our subclass, class car S. Okay. So I'm using SS suffix for all these Scala related classes. The reason is in my Java classes, I already have the vehicle and car classes. In the same project, if I have the same class name referring to both from Java and in Scala, they will collide like. So there will be a constraint. So you cannot use that because you have already used that class name and that dot class file will get generated after compiling, and the same dot class file will gets generated even from Scala. So then there will be an error message. You will not be able to save that. So that's the reason why I have suffixed yes into all our. So you can merge, you can club your Java classes and Scala classes both into the same project as I am doing now. So in my test Scala, so in my default package, I have some of them are like .java classes. So inheritance test.java and simple class test.java that we have seen yesterday. Simple class test yes.scala for Scala. And inheritance test.java for Java and inheritance test yes.scala. Okay. So I can combine both Java and Scala programs in the same project, but you have to make sure that you are not using the same class for both Java and as well as Scala. Now, in this child class car S, okay. So you're not able to hear me, Purushottam. Is it the same case with others also?
No, I can hear Shiva.
Kalpana, Gopi? Okay.
I'm able to hear Shiva.
Okay, thanks. Yeah, I think some speaker issue from your side, Purushottam. Okay, okay, yeah. So try to ping me those any chat messages. I mean, if you feel like it's generic, try to ping to everyone so that everyone can get to know that. So what's going on? Sometimes if I simply answers your question, they might not be able to get the context of it. Now, so this car S. So here you have to closely observe few things. So this val ID, val year, val ID, val year. So I am overriding them. Override val, extends vehicle S, ID, comma, year. So my superclass ID and year, the constructor parameters, I am overriding them in my subclass constructors. So I'm able to override them. Now I have a model here, the same model that I am trying to refer here in the child class, just model equal to Swift. Okay. So when the model is Swift, I'm overriding the brand also. Override val brand equal to Maruti. And overriding the superclass toString method implementation as well. ToString equal to super.toString ID and year equal to year in subclass. and I can, yeah, anyway, I'm printing them here. So model and brand. Okay. So now, same like in Java, so I created one parent class vehicle and one car class child class and inheritance test main method. So I created an object, just two parameters, 20 and 2015. 20 is my ID and 2015 is my year of manufacturing for this car. So 2015. Now I created an object v1. So on this, I'm calling v1.model, v1.brand, and v1. So v1 will print this ID year in subclass, and the same from the parent class as well. Now let's see, and I want you to find out those differences. So here this dot model and this dot brand got overridden, whereas I could have printed. So I will print this here. Same, this dot model. Sorry, brand, right? Or even just brand is fine. Okay. Now, so that is the brand in parent class and these two brands in child class.
Shiva, you are just creating an object of child class, right? Not the parent class.
I'm not creating, in both Java and Scala, I'm not creating the object of parent class. I'm creating an object of child class. In turn, I'm extending that constructor. So here in Java, so I explicitly called that. So I'm from my child class constructor, I'm explicitly calling the parent class constructor. Okay.
Yeah.
So here, if you observe, when I say extends vehicle S,
Why do we need override for the variables too?
I want you to answer all these questions. Let me complete the running and my part. So then I will come to the questions. Okay. Now, so I ran this. So I created a car class object, and the model is Swift, and the brand is Maruti, which I set in my child class, right? So in my child class, these things, so on V1. Now, if I print V1, so what is happening? The super dot toString. So if I go there, so in my super dot toString, ID is, so whatever that I pass in this child class constructor, ID 20, so the same thing, ID 20. Year is 2015, and model is, so model is this dot model. Swift, brand is Maruti, and again in my subclass, ID is this and year is this, and in subclass. So what's happened? Any difference?
You're overriding the super class, right? Only the def to string.
Mm-hmm.
So you will get this. When you call this child class, you should get child class values, right? Why are we getting Maruti when you're calling the okay? Okay, when there is nothing, we call the superclass method, right?
Mm-hmm.
So when we say super dot to string, so we are just overriding here.
Mm-hmm.
So when I say to string, I should get the method which is executed from cars.
The super dot to string means which one will get executed?
You are calling when you add superclass, when you say super dot to string, but you are overriding it here, right? It is just a definition. You are not calling.
This super dot to string means I'm not calling here.
That's where I'm get confusing. When I say to string, you should pick from this, right? When you see the scope. One second, 1 second. Okay,
You have
super
a,
dot
I mean, you
string.
have basic understanding gap in a definition and a call of a method, both in Java and I think. So see, the same the super dot to string I use. Here am I not calling in Java? This doesn't mean I'm calling this. So super dot to
Okay,
string means am I calling this or not?
you're calling. Okay, come back to the Scala class.
Mhm.
Okay, then year, what is the year you're passing it in child class?
20 and 2015.
Okay, so when you say super dot to string, you are calling the super class method, then the year from the cars.
Okay, let me understand. Let me explain you guys the differences as well. Okay, let me not confuse you. So since putting you into trouble, let me explain you clearly. So the difference that you have to observe here is that, so if there are a constructor parameters like ID and year, these two are constructor parameters. So for overriding them, I need to explicitly specify the override keyword. So for overriding them, I need to explicitly specify the override keywords. So here, you know this val IDs and val year, nothing but they are constants. Once set, they are set, right? So we are using the constructor parameters as vals. These two are constants, and those constants we are overriding them in the child class. So you may get a doubt, if it is a constant, how can you override? So constants can also be overridden from the child class, both in Java and as well as Scala. It is not something new. Okay? So constants can also be overridden both in Java and as well as, for your better understanding, constants vals can also be overridden both in Java and Scala, right? So that I am overriding here. So if you observe in our Java code, so model is a constant in my parent class, and the same I have redeclared there. So public final string model. Now, so this dot model means here this Maruti I'm getting. Now, so the remaining two other fields, ID and year, I didn't declare them here. Only the new attribute fuel level I declared in the child class. And if I have to override the constant, I redeclare that here. If I don't redeclare that, I will not be able to override the constant. So that's the reason why I'm giving again override val here. And otherwise, I could have directly given ID, comma year. Same like here. Now, so coming, these two are the constructor parameters. Now, so model is a variable and brand is a constant. Again, I am overriding model in my child class. For overriding the model, I don't need to specify, I don't need to redeclare that. I can directly use that variable in my child class and override that. The same way that we did in Java as well. If you see here, did I declare ID or year anywhere in this? No, right? But still, I am able to call this dot ID. So it's pointing to vehicle.id, right? I'm able to use this. I'm directly using this. I'm not redeclaring anywhere in the child class. So that's the advantage of inheritance itself, right? I don't need to redeclare and I don't need to redefine the methods. Now, I'm able to override the model of your superclass, so to Swift, and override val brand. So if it is a constant, if it is a val, I need to give the override keyword and val explicitly. That means redeclaring that. If it is a constant, constants needs to be redeclared. Variables, vars do not need redeclaration. We can simply reuse them directly in child class, but constants need to be redeclared. In the child class to reuse them. Okay, so these are, so brand is a constant. So since if I need to override that, so I use the override val. So it's as good as like, so val brand equal to this. And since I have the same in the superclass also, I'm using the override key. Now, so here, when I call this, when I override them, even the superclass, the fields got overridden. The proof is that when I call the toString method of the child class, in turn I'm calling the super.toString. Ideally, it should have given me ID 20 year 2015 and model. So it should give me, if I call this dot model, so here this dot model, this should point true. Fiesta, and if I call this dot brand, let's see what will happen.
This means that time it will refer to the parent class, right?
Yeah, let's see with the example. Okay, let's not come to confusion. No. Brand. Okay.
Brand is Maruti.
Now here ID 20, year 2015, model Swift, brand is Maruti. After that, again, brand is Maruti. So, is there any difference between I call just a brand variable or this dot brand? So here, override means completely overriding the superclass values as well.
Okay, in this case, if some other class,
You have completely overridden your parent class values as well. And even in your parent class method, when you are so at the time of overriding, the model is now freeze, and this brand is now Maruti. So I overridden the parent class variables as well. So overriding means, so here it goes that level. Like it's not like in the child class only these two values will be available. In the parent class, you will still be available with these things. Okay.
what in
If you
case
don't
another
want
class?
to override, if you don't want to override them in your parent class, there are some attributes that you don't want to override them. So keep them as a vals and don't redeclare them here. And those things will be available in your parent class, and then you can reuse them. If it is a variable, you will always be overriding that value also. So since you are coming from Java background, you may not be easily able to digest this feature. Okay, because there you see this, the parent class variable values. So when I say ID, which is a variable, and where year is also variable, when you call from here, so then that time, so it still gives you these values. If I override that, let's say this dot ID, and here super dot toString. So this 20 gets printed, and let's see. So 20, it should have, so when I override the ID value, so I'm pointing to this dot model, like, so variable is anyway got overridden, right? If you check here, so return ID of this dot ID, and here, right? So in this println of C, I'm calling this toString, correct? The toString, where am I going? So into the parent class toString. So here, this dot ID, it should be 10. Reason is I'm passing 1 actually here. Okay, it should have been 1 there. So initially it is fine. Initially it is, if you want to make it more clear, I will put one more statement after this. And in my toString also, I'll put that. Okay. So initially when my superclass constructor gets called, my ID was 10. And once the superclass constructor got called, so even this ID got changed to 1, right? And now, so here, even in parent class, the ID got changed. It became 1. So that's the same behavior for variables, right? And now, coming to constants, we are not able to change that. You have a 1 value in parent class and 1 value in child class. So here, this dot ID, after constructor, all the statements get executed at the end of it. And the toString also, you can see in the toString, if you see here, so I made it this dot ID as 20 and this dot model as Maruti and this dot fuel level. When I call super dot toString, in the toString, it is pointing to super dot toString means here. But here in this dot ID means it should have given you 1, right? So in the constructor of vehicle, so it printed 1. But whereas in the toString, this dot ID means it referred 20. That means the variables will get overridden by your superclass statements, control statements. After that, if I didn't have given this dot ID, so if I give this dot ID as 20 from my subclass, so it overrides your parent class variable value also. Whereas this dot model, which is model is a constant, it is not a variable. Model is a constant. Now, if I point to this dot model here, okay, so this dot model is a Maruti, but whereas super dot model means it is still a Ford only. So in Java, if you override the variables of parent class, even in the parent class, they gets overridden, right? If we override variables in subclass, okay, for example, if we override variables like ID in subclass, it overrides the value of it in parent class as well. Value of it ID, that means ID in parent, ID in parent class is also 20 now, but not 1 as set by super constructor call. Okay, so this inheritance concept is a bit technical, like so I'm trying to conclude these statements with the help of examples. Okay, I hope you guys are trying to catch them up. There is nothing theory in Scala to explain, so that's why I don't much depend on the slides. I purely depend on the examples. If I don't show you here in the result, if I just keep on making the statements, so they will not reach you.
Shiva, suppose another class overrides that. Now you have vehicles and cars, and when in Java I understood, but when it comes to the Scala, when you override it, it really overrides the superclass values too. But when another,
Here you are not overriding the superclass values in Java.
not in Java, in Scala.
Then ID, how come it became 20 in parent class also?
This is in Java, right? Whatever example you are showing.
Yep.
Because that was, it's a variable, it was not a constant.
Okay. Yep.
And there, when you do that, like, so only when it is a constant, we use the variable, right? Keyword. Sorry, override keyword.
Yep.
If it is not val, for var, we don't use override.
Correct.
Okay. But when the case of val, let's say that one class overridden and you assign some ABC value. So another class will override the, again, vehicles. It means, does it has the, again, the whatever the child class will provide the value, that value will be there in the parent, right?
Correct.
So whatever the child assigns, that scope will be there.
Correct.
Okay, so not with the parent scope, basically.
Exactly.
Okay.
So here, the scope of your, just to make you that, the scope of constants will be, constants will also be, the scope of constants will also be overridden in the parent class by the child class value in Scala. Whereas this is not the case for Java. Okay. So values, the scope of variables will get overridden. Okay. Variables do not need redeclaration. We can simply reuse them directly in child classes. The scope of constants will also be overridden. Let me write this way. Scope of variables will be overridden in the parent class by child class variable, both in Java and Scala. Observe ID in Java example and observe what is that I gave you here, model, right? Model in Scala example. Okay, so for your understanding, I will give you these notes also into the slides, and I will give you the examples as well. So now you are able to override your constructor parameters. You are able to override the constants. You are able to override the variables. Okay. Extending a class. Differences. Between Java and Scala. Okay. So we can override only vals but not the vars in the class constructor. For this statement, I didn't show you example. Now let me try to show that as well. Okay. Now, for overriding class variables like model, instead of constructor variables, no need of override and var keywords. So this we have seen. Just let me show you one more example, then I can explain you all those statements. Here, what if I have var some str? Let's take one attribute, which is of a string. Okay. So it is saying that the error message, not enough arguments for constructor vehicle. So vehicle has unspecified value parameters, str. So here it is saying that when you are extending enough, right? So there are not enough parameters here. So I'm pointing to str. Now not found value str. So if I extend here, override var str, which is a string. Now, seems like the error has gone. Seems like the error has gone. But if you save it and try to run it, this is a runtime error that you see there. Project test Scala contains build errors, showing you the build errors. Now it is showing you, it's executing that as much as it can. But if you observe here, error message. Okay, sorry. I didn't give the value there, right? So I'm passing the third parameter. Let's see, not enough arguments for this. Now you can see the error message there. Overriding variable str in class vehicle s of type string, variable str cannot override a mutable variable. From constructor parameters, you cannot override vars. If you have any vars in the constructor parameters of your superclass, you cannot override them. So that is one reason why we default go by vals in the superclass constructor variables. If you want to override them, you'll not be able to do that. As a general practice, as a general standards of, so one of the coding standards as part of Scala, constructor variables declaration, constructor parameters declaration, you always declare them as vals. How does that matter to you? Whether val or var, you are still able to override them. Okay?
No, but when you're saying, but when it is var, you cannot override, right?
Var constructor parameter, if it is a var, there is a dynamic error that you get from the Scala executor that you cannot override a mutator by another mutator with a constructor parameter when it is in constructor. So if you don't want that, I mean, if it is fine, you can keep that inside your class variable. Whereas you are
That
able
is
to
available, right?
What is it?
That I can override it. If it is within like model, it was overrideable, right?
Yep. Model, you are able to see it already, right? You are overriding it. You are able to run it. You don't see any error messages.
Okay, only in the case of constructor, we cannot use val.
Var.
Var.
You cannot use var. So that's why if you want to use something, any var mandatory, and so then you can use that inside your class variable, like a class variable, not like a constructor variable.
Okay. Let's say that I have one var, one val. So I cannot make any constructor, any classes can inherit, right?
In the constructor, right?
Yeah, let's say I have one val, one var.
Yep.
So if I have to inherit,
Yes,
I can't.
correct. I got your question. Yes, that's correct.
Okay.
Okay. Yep. Now, so here, so that's the first statement. We can override only the vals, but not vars in the class constructor. That statement. And for overriding class variables, not the constructor variables, okay, in class constructor parameters. Let me be more specific, okay. For overriding class variables like model, instead of constructor variables, no need of override keyword and no need of var keyword also. Okay, no need of override, no need of var keywords. And so that we have seen. Model, I am able to use that as it is without any keywords. And for overriding class vals like brand, we need both override and val keyword. Both we have to both override and val have to specify that. To be prefixed in subclasses, that means redeclaring them. It means redeclaring the constants in child class. Okay, so constants vals can also be overridden both in Java and Scala. But variables,
Val I have to use override, right? If it is within the class.
within the
See, if I have a super
even
class,
within the class or constructor parameter, both the places we used override. Even for constructor val and within the class val brand, for both of them I used override val, override val.
Okay, got it.
Yeah. So variables, vars do not need redeclaration. We can simply reuse them directly in the child classes. Okay. But constants need to be redeclared in the child to reuse them both in reuse them it is same behavior in both Java and Scala, or it is same in both Java and Scala. The scope of the variables will be overridden in the parent class by child class variable, both in Java and Scala. Observe ID in Java example, so which got overridden there, and model in Scala example. If we override variables like ID in subclass, it overrides the value of it or ID in the parent class as well. So that means ID in parent class is also 20 now, but not 1 as said by super class constructor call. So this the scope of the constants will also be overridden in the parent class by child class value in Scala, whereas for this is not the case for Java. So in Java, what was the constant? Yeah. In Java, so model is Ford in superclass, but Maruti in child. But in Scala, it is Maruti in both the places, in both parent and child. Okay. You can override only vals but not vars. This is not needed from you here. Okay. For your reference, I will put these programs as it is. So this is all about the inheritance. Okay. Okay. So I hope these examples will help you understanding those supporting statements. So that's my intention. So here I don't need all these calls. Let me take out these comments. Okay, so I hope it makes you clear understanding the inheritance in Java and as well as Scala. Okay, now, yeah, let me jump on to different topic now. So packages and import. So we were seeing this package statement, but we didn't talk about it much, right? So now the packages. So it is also similar to Java packages, but there are a few more extra features that you can see. So the default two packages that gets implicitly imported in any Scala program are java.lang. Underscore and scala._. So in Java we have star, in Scala we use underscore. They both refer to the same. Underscore means like a star only. The underscore character is similar to the star character of Java. So it imports all the classes in this package, java.lang package and scala.lang.star. Yeah, scala.star. No. Different ways of creating packages and classes inside them are. So same like your Java syntax, you can specify this way, package com.test.store, and you can start writing your classes there. And within the same .scala program, you can write multiple classes. Within the same .scala program, you can write multiple classes. You can put them this way also. Package com.test.store. After that, you write your class. And after that, again, you can write your own another package com. Or you can write a nested levels of package. Or you can open the curly brace, package com.test.store, open a curly brace and close the curly brace. And after that, you write one more package com.test.market instead of store. And inside that, write a class market. Here, write a class foo or class store and all its implementations. And once you close the package scope of this, you can open another package with com.test.product or com.test.market, and you can write your market class or product class inside them. Now, if you can also write them in the nested this way also, package com, inside that package test, inside that package store. It also refers to the same com.test.store when you are pointing to foo. So another advantage with this is that you can write your other classes at this test package level in the same curly brace and in the same .scala program. In the same .scala file, you can write few other classes which are within the scope of com.test package and few other classes which are within the scope of just com package.
You have same class in COM and test, both are different, right?
Yes, both are different.
Because the scope is different.
Yep, they both are different.
Okay.
Okay.
What
So
is the standard
functionality wise, it is same. Only from syntax point of view, you have more flexibility that you can write many packages in the same .scala, and you can use curly braces to specify, put all your classes within that. Or this is these are like three different ways. This is one way, and this nested is another way. Okay, and yeah, this is nested is another way. This is same as your Java type. And while importing also, you can use this import statements with multiple classes at the same time. Anyway, import java.io._ is fine. It will import all the classes in that package. But in that package, you don't want all the classes. You want only a few specific classes. You can specify those classes in the curly brace as comma separated. This syntax is also something new in Scala. So you can, in one line itself, you can specify as many classes as you want. Okay, and one more advantage with the syntax is that the functionality wise it's same. Both package and import, they both are same. The advantages is that you can use these statements, you can use the import statements at any place inside your Scala program, anywhere, including the top of a class or within a class or object or within a method or within a block of code. Anywhere you can use and import classes and import packages or import objects. Import statement can be used anywhere, but package, you have these three varieties that you can use with. Okay, you cannot use package statement inside a class or inside a method, right? That doesn't make sense. Package always needs to be outside of your class, but these are the three different syntaxes that are supported. But import statements, anytime, wherever you are going to use your file class or IO exception class, just before that line you can import it. But as a practice, just to have all the imports in one place, we still follow the same standard Java standard, like declaring all the imports at the beginning of the program as a coding standards of Scala developer. So we follow the same, since we all came from the Java background. So if we are writing Scala, but we use this syntax a lot. So specifying all the classes of that package in just one single line instead of writing multiple lines like in Java program.
Does it load only few classes when you do that?
Yep.
While loading?
Yep.
Okay, and while specifying the import, what is the scope? Suppose if I don't import at the top of the class or top of whatever I'm doing, that's the standard practice.
Wherever you import, from there onwards it will be available.
Okay, so if I import it within only one class, that is available again.
From there onwards it is available. There is no scope like that.
Oh, so there is no scope associated with that.
Yeah. From there onwards it is available. That's it.
Okay.
So until then it is not available. From there onwards it is available for your control.
Okay, got it. Okay, fine.
No.
When you are importing at the top, if you mention the classes, specified classes, loading, you are saying it loads only few classes. You mean to say that in a memory wise it is faster? Because it loads only few classes, not everything.
No, I'm not talking about any functionality difference between Java imports and here. There is nothing faster, nothing slower here.
Oh.
Nothing functionality changed. Syntax, yes, that's it.
Okay.
Okay. Yep. Now, yeah. So let's discuss a few points about access modifiers or access specifiers. So private, protected, and public. So you anyway know this from Java concept, just to reiterate them here. Okay. Now, so private member is visible only inside the class or object that contains a member definition. Maybe I should have moved this. So class outer and class inner, when I declare something as a method as a private, so then that is private 2. So that class inner is only able to access this F method. And any innermost classes can also access. So since this innermost class, which is declared inside the inner class, can also access this F, but not the outer classes. Okay. So I'm not recommending you to use the inner classes or these things here, but trying to show you example that if you declare anything as a private, so that is available within the scope of that class, and inside that, if you have any inner classes, in those inner classes also you can use them, but outside of that class it is not available. Okay. And package protected members are at like a derived classes can only be able to use them, but not like a package level scope. This is a bit difference.
Protected in Java, the class within the package, any class can use it,
Yeah.
right?
Within the package, so but not even by other classes in the same package, unlike Java. That's why I mean this.
When you say private, only to that scope.
Yep.
Only to that particular class.
Correct.
Okay.
So when you say protected in Java, so that protected can be used by all its derived classes and as well as all other classes in the same package. Both the derived classes and as well as package classes can access in Java. But here in Scala, only the derived classes, but not even the other classes in the same package. If you see, I have a package P with scope this. Okay. Let me write this into. Protected test, right? And one more difference, if you observe here, I don't need to maintain the same class name as your .scala file name. In Java, the file name and your public class name should match, but here there is no such constraint. Here, if you see package P, so any classes that I declare now are within the scope of this package P, package inside the package P. Now inside package P, I have a class called super and a function called F. Okay, so protected, this is protected. Now I have a class called sub, which is a child class of super. Inside that, I am able to call F. But in the same package P, I have another class, but it is not a subclass of super. But from here, I'm not able to call F. Right? So it's saying that, so method F in class super cannot be accessed in p.super. It cannot be accessed in P. Okay? So method F in class super cannot be accessed in P. Super access to protected method F not permitted because enclosing class other in package P is not a subclass of super in package P where target is defined. Okay? So that's the scope. I moved that.
Only if it is protected, you can access it, right? I mean, subclass can
Only
access
if it is a subclass, then only it can access it.
it. Okay.
Okay? And there is no keyword of public here. You don't need that. if you don't declare private or protected, then it is public by default. So a public member can be accessed from anywhere. Every member not labeled private or protected is public by default. There is no explicit modifier for public members. Okay, so that is about public. Now, coming to the package. Okay, coming to the package, package scope private variables. Inside the private, I have one more example. So private to a package, but not, private to class we have seen, private to package also we can see. Okay, so that is, I have package society, and inside that nested package like society.professional, which is a package professional, and inside this I have a class called executive. Okay, so this is as good as like society.professional.executive class. And now I have some private variables, private of professional, where work details is null. So this work details is a variable, and this scope is, this is a private variable, but not just to class executive, but this private variable is available in the professional package. So any class in the professional package can now access this var work details. This is as good as your protected variable in Java, right? Protected variable in Java can be accessible by any class in that package.
Shiva, can you please come again? This one I did not get it.
So if I declare I have this private variable, private var work details. Okay. So if I don't declare in the square braces, if I don't declare the square braces, which is a professional here, if I remove this square braces, so then it is just private to this class executive. If I remove this highlighted part, okay, so then now work details is local to this executive. Outside of executive class, this will not be accessible. Okay, getting my right?
Okay, so private to executive class.
So if I specify private to professional, which is a package name, that means this variable is a private, but can be accessible within the scope of this professional package, but not outside of. This is a private to package, but not private to class.
Okay, got it. Okay, you are mentioning this is not there in Java, but you are mentioning this is another way where you can provide scope to
Package.
at a package level.
Correct. Okay. And def help another, so which is executive, another object, another dot work details, all those things is possible. And inside, outside of this class executive, if you want to access that, you can try to. And
One second, Shiva. What is that another executive like in
this is
within
an object. That's it. Object of executive. I define a help. It takes a one argument, which is a another, which is executive. This is a method.
Okay, got it.
Okay, so this dot secrets I'm able to access. Yeah. So there is one more scope like private of this. So if I say private of this in this, so this is specific to this class only current object, but not even to another. You can only access by this, but not even on another object. So this is a bit confusing, but I don't recommend to use this. So these two will be helpful. Like, I mean, this package private variables are helpful. Okay. Class level private variables are also fine. Private var secrets and private of this var secrets is a different. There is a difference. Private of this var secret means you can't even use these secrets for another object of the same class. If you see here, def help another executive, another dot work details, I'm able to access this work details on another object. So this dot secrets, it points to the same. So it will get that this dot secrets. And another dot secrets, I can't access on any other object. If I create an object for that, I will not be able to access that.
Then what is the use of it?
Only class level you can use that. Inside the class, if there are any methods, and methods, they can directly access that this dot secret. Here, this dot secret means in this class, this refer to this secrets method. In the same current object. If you have another object from that, you can access. There is, yeah, I don't, that's why I'm telling it like, I don't like it. I don't recommend it. Okay. Yeah, so let me complete just 2 more slides, and after that I will give you a break to you here. So that is one thing. Now we have seen methods that takes parameters. Now I have an example. So something like println. So println can take any number of arguments. So there is no fixed number of arguments for println, right? All those will get printed. So that is achieved through your var args feature in Java. So we can do the same thing in Scala also, even more simply. So we can define a var args field in our method declaration by just adding a star character after the field type. So if I have a method print all strings, a string star, so it just prints me. Don't even need the.
It means we have passing an array of strings.
Yeah, array of strings. Any number of parameters that you can give. It need not be an array also. You can pass one string, you can pass 2 strings, you can pass 3 strings. You cannot pass any string. Even then it accepts.
How do we know how many I have?
You don't need to know that first thing. Your function will take care until it ends all the list of parameters.
Yeah, if I have to say students, I don't know how many number of students, I'll give it a string.
You have to count them inside your function.
Oh yeah, while processing, okay, I have to say count.
While processing, you have to count them, that's it.
Okay, got it, thank you.
Okay, now I declared this function. This is same like the functions that we have seen, def print all strings. If I could have given only the string without the star, then it is as good as like any regular function. Now, since I gave it as a string star, it is like a collection. Now in this collection, now I'm calling it like strings dot for each. For each is a method on one another method on the collection. So which executes the function that it takes as parameter on each element of this collection. So as English word also, if you see like strings dot for each string inside this collection. So run this function println. Now if I call println, print all. So if I don't pass any parameters, it accepts. If I pass just Kalpana, it prints this. If I pass 2 parameters, Madhavi. It prints that. If I pass 3 parameters, it doesn't care how many I'm sending. Okay. So
I
ideally,
have to
the
access
process
specific
is
object.
ideally the process, the standard that what I'm trying to say is, if you want to have a multiple arguments, I mean, var args, the same similar type of arguments, you can't guarantee how many you may expect. Then use the star, and on that collection for each, write your own function instead of println here. Write your own function and call that function from here. What is the process that you want to do, or what is the process that you want to apply on each element of those arguments. Okay.
Shiva, if I have to specifically access one or two elements, suppose let's say second element or third element, how do I access it?
You have to declare them, then that's no other way. Just keep on counting them. Just strings instead of for each, then you should not use the for each method. So then take the count of them, the strings count, and take that index.
Okay, and loop it.
Yep, loop it.
Okay.
Okay. So that is methods with var args. And now launching an application as a Spark application, I mean Scala application. So if you want to run as Scala application inside your Eclipse, two things that you have to maintain. Let's say if I remove this, will I be able to execute this? Can I see the run as Scala?
Extends up has to be there, right?
Yep. So those are the two ways that I can make it as runnable. Otherwise, it will never be runnable. So if I have an object test, not even the capital object, it's a small object test. So then will I be able, now also I don't have any error messages. Can I able to run as Scala application? No. If I inside this, if I write a main method, same like public static void main, def main, args, which is array of string. See, now save this. I created as a class, or you see. Now I can see this run as a Scala application. So thing is, you should have at least one object to make your Scala program as runnable. And inside that object, either you should have a main method, or this object should extend app. Okay, if you comment this out, then also no problem. Okay, so if you are extending app, then also this becomes a Scala application. So these are the two ways that you can make your Scala as a runnable application. Define an object with a properly defined main method. So if you want to take the command line arguments, we have this args. Okay, args of 0 first argument, args of 1 second argument, that way. This is using main method. Okay, here also you access the same arguments, command line arguments. args of 0, args of 1, args of 2, like that. Okay, so next we'll see singleton objects, companion objects in our next class. And case classes, which are very, very important, we'll discuss them. Traits and abstract classes and exceptions. For all these things, I need one another class. And collections, I might need collections. I need at least 20-30 minutes. So building Scala applications, I will try to show you through Maven, or I will completely skip this, both Maven and these two, and I will directly cover this building the Scala applications and during Spark sessions. During Spark examples, I will try to give you that.
What is Maven?
It's one another build tool.
Okay.
Build tool. Yeah, maybe that is like you have to like a prerequisite for your next class, like you get the basic understanding. So can you explain society and this for private access specifier at package level once again? Okay, I'm coming there. So when I say private of this, so that is accessible only inside that class, not even by another object of that class, which is a very vague, even in my perception. So that's why I don't recommend that. So when you ask the second example, private of society or a private of so private of professional or private of society means this work details is private to this professional package. So anywhere inside this professional package, you can use this work details private variable. And private of society where friends. So this friends variable is private to this society package. You can use that anywhere. Okay. Can you repeat once the where args? Okay, so I will come to that. Yeah. Now, are you clear about this private of professional or private of society? Even if you don't understand the private of this completely, that's fine. You ignore that. Don't use that at all. I don't find any usage for that.
Yeah, if it's professional, then we can use outside the class, like if we import the
outside
package.
the class, but inside the professional package.
Okay.
And if it is private of society, you can this secret private of society of friends. This can be used. Even this can be used outside of your class, but inside your society, outside of executive, outside of professional, but inside of society.
Okay. Got it, sure.
Okay. Yep.
Thank you.
So for your question, Purushottam, var args feature, I mean, it's pretty same as your Java var args. Only thing is here it gives you even more simple syntax, simplex syntax that don't need to worry about. So just specify. So if you expect a same data type arguments, any number, when you can't specify how many number of arguments that you get. So this is the way that you can achieve. If you have multiple data types, obviously you can't do this. So they all should belong to the same data type. Multiple arguments with same data type, you can achieve with this feature, string.star. And inside that, as Mamta was asking, if you want to process for each element differently, you can look through them. So just access them strings of 0, strings of 1 like that. Or for each element. Generally, since they all belong to the same data type, and they all needs to be processed the same functionality. Most of the times, 99% of the scenarios, you will use the for each, and inside that, what needs to be done with that for every element in that collection. Okay, then if you pass any number of arguments, then that will apply the same function on each of those arguments. There is no constraint on the number of arguments should be this many only. Is it clear now, Purushottam? I think I'm not able to hear you. So I need your help to install Scala on Cloudera. Why, Mamta? I mean, you didn't install?
No, I think one day I tried, there was some issues and left it like, so I didn't want to mess up because previous.
Okay, why don't you refer the video and do it once and then come back to me?
Which video?
Our Scala installation video.
I can't open the videos at all.
I gave you the passwords, right?
No. I can't. When I open it, it gives some error MP4 files.
Why don't you install VLC Media Player?
VLC Media Player. Do you have it? If you can place it in the
VLC Media Player, you can find anywhere, right?
No, because I have it. I tried opening in that. That's the reason I'm asking you.
It's playing with the default Windows Film TV, these applications also. I'm not sure why your laptop, I mean, whether it's a problem with your laptop or not able to see. All these things, I'm not even playing with my VLC player or other players. Plenty of players they can play with for you.
So whatever you are using it, if you have it, please share it.
Okay.
Maybe some, I don't know what is the reason.
Okay, then I will put that vlc.exe also in the Google Drive.
Yeah, that would be great. Thank you.
I mean, my intention is that not to spoon feed you every time. Okay.
Yeah, that's the reason.
Scala installation, just Windows and Linux, I spent one day, like almost like one session. So mostly you will be able to figure it out if you look at the videos.
Yeah. If you have a video, I don't mind. I can go through that.
Oh.
Which session 1? Day 1 video?
Day 2, I think. Day 2.
Okay.
It's day 2, Shiva.
Yep, day 2. Yep.
Okay, I'll look at it. Thanks, Shiva.
Okay. Yep. Thank you. Now coming to the assignments part. Like last week, I gave you some assignments around these questions. So installing Eclipse, Scala, and Eclipse IDE for Scala in Windows and CentOS, both Windows and CentOS, and defining some variables and display them in shell, write a function and find the maximum of 3. So all these 3 are like simple things. Now let me put a few more to this this week. So based on the topics that we have discussed so far, let me add some few things. It's one and the same file. Right. So since we discussed the control loop statements and the collections and the OOPS concepts this week, so you'll be able to handle all these things. Write a Scala script to find the factorial of a number using loop. Write a Scala script to find the number of words in a string using for loop. These two pretty simple. define an array, initialize the array, and display the values in array one by one using while loop. And define array, add some values, convert that array to list. Okay, explore that to list from array to list and perform your list operations on that. Define a variable type set. This is not needed at this moment, and add around 5 values and display those values. Now remove the third and fourth values and display the updated set. This might be a bit difficult at this point for you. So define a variable type list, insert around 10 values, find the minimum and maximum in the list. Yeah. Let me take out this for now. So define a variable set list map tuple, find the size of the given variable. All these things. Let me take out these things which I didn't cover now. Okay.
Shiva, don't delete it. Just put it at the end or put a scratch.
No, I will give you sometime next week. Don't worry. Okay. Don't worry. Now, what I want you to do is write Scala class with multiple auxiliary constructors. Okay. So after all the Scala topics are completed, then I will be giving you one dummy pizza-based pizza ordering project, so that there you can apply all functionality kind of stuff. For now, I'm more worried about you get familiar with the syntaxes and everything. So write a Scala class with multiple auxiliary constructors and create objects with multiple constructor parameters. Okay. Okay. Now write a employee manager inheritance classes. Okay. So this is a typical, like employee having few attributes and manager is having 1 or 2 other extra attributes. Inheritance classes, and demonstrate the inheritance concepts. Inheritance concepts of overriding constructor vals and class vals and class vars, with example by taking some attributes like salary, bonus. So bonus for manager, salary for employees, and department common for both, and ID for both. So these attributes. And salary for both manager and employees. Like this salary comes with both, I can say. So that's one thing. And what else? Make it as a runnable application. So that covers anyway. And try example, like show examples on, or write examples. Okay, write examples for access modifiers. Examples describing the access modifiers. Describing for access modifiers: private, protected, and private package scope. Okay. So for public, anyway, nothing needed for there. Package scope. And what else we discussed this week? So access modifiers, making an object, making a Scala application, var args, and primary constructor, auxiliary constructors, in inheritance that we talked about. Yeah. Write example to show the entire body of a class. Body of a class is a constructor. Okay. All Java data types support Scala. All Java data types are supported in Scala or not? Yes. Okay. You have to import them if you want to be specifically use the same Java data types. Okay. So I think that's enough for now. And yeah, pattern matching. Instead of write example for switch case statements like tenth one, write example for switch case. Since we don't have switch case statement, this is a pattern match or case statement. Switch case statement by taking the grades of student scores. Okay, like student score greater than 35, just passed or something, greater than 60 first class, and greater than 70 distinction, and greater than 80 some other grade, 90 some other grade, like. Okay, so give me those examples, and remaining these things I will not delete. I will keep them for your next week assignment when I complete them. So I'm trying to complete Scala next week, and at least one or two. I'm planning to take at least one extra session next week. So that would be either my Saturday night timing, evening 7 p.m., which is your 9:30 a.m. EST. Okay. So I will confirm and I will send the invitation. So next week, probably expect for 4 classes instead of 3. Okay. I'll put that.
Shiva, can you share the link for the shared folder? I'm not getting it.
Okay. No worries, I will share it. I'll place this Scala assignment 2 in shared drive.
3 assignments for new
No,
assignments or
only one assignment per week. Okay. So already first assignment I have kept there for the last.
okay.
There's the second one for this week,
Okay.
and
And
yeah.
today's slides too?
Today's slides too I will upload. Okay.
Okay, thank you.
I will upload today's slides as Scala part 2. Okay. And for your, as per your request, like you need a VLC player, right? So I have a VLC.
Yeah, whatever it is. Thank you so much.
How to Spark train first. So that also I copy paste. Okay. So remaining things I will upload once the recording gets saved. Okay. Any questions before I log off? Okay. Thank you guys. Thank you very much. Bye bye.
Thank you, Shiva. Enjoy your day.
Thank you. Bye bye.